Our journey begins in the heart of Britain during the turbulent times of the Second World War. While the British were quick to recognize the importance of speed and maneuverability in aerial combat, they also understood the significance of raw power. Enter Frank Hafford and his team of engineers. The unruly powerhouse development and politics of the Napier Sabre engine. Hi everyone, and welcome back to the Jaxom Talks channel. Today, we're not just looking at horsepower. We're diving into an epic tale of engineering genius colliding head-on with wartime production chaos and political anxiety. Our subject today is the Napier Sabre, the 24-cylinder beast that powered the legendary Hawker Typhoon. This engine wasn't just powerful. It was the ultimate high-stakes gamble for the RAF, and its development history is pure drama. Designed by Frank Hafford and his team of engineers, this engine was the epitome of British innovation and ingenuity. It represented a significant leap forward in aviation technology, boasting an incredible power output and an innovative design that set it apart from its contemporaries. The H24 marvel, a design pushed to its limits. During the Second World War, there was a simple goal in the aeronautical teams, a piston engine producing 2,000 plus horsepower, but getting there was anything but easy. Rolls-Royce had the mighty and famous Merlin, which would eventually hit that mark, but Napier and Son took a far more radical route. They created the H24 configuration. Imagine that, 24 cylinders. It's not a V engine, but an H block, essentially two horizontally opposed flat 12 engines stacked one atop the other. All of this linked into a single yet staggeringly complex crankshaft. Why this unusual layout? Because it offered a fantastic power to weight ratio and, crucially for aircraft designers, a very compact frontal area. It meant a cleaner, more aerodynamic nose for the plane it was installed into. The Sabre was a world first, the first engine to reliably break the 2200 horsepower barrier in testing. But the advantages didn't stop there. The Napier Sabre was also incredibly lightweight, weighing only 770 pounds, approximately 349 kilograms. This characteristic was particularly important for fighter planes where weight was a critical factor in determining performance and maneuverability. Despite its power, the engine was compact enough to fit into the engine bay of existing aircraft without major modifications. The sleeve valve system, triumph and torment. So why then did this marvel of engineering never end up in the planes that could have benefited from it? To understand this, we must delve deeper into the development process. By the end of 1942, the prototype engine was ready for testing. Initial runs were conducted at the company's test facility at Acton in London. The engine performed exceptionally well, exceeding expectations and demonstrating the potential it held for the future of aviation. The results were so promising that the Air Ministry quickly placed an order for further development and eventual production. In January of 1943, the prototype was shipped to the Royal Aircraft Establishment at Farnborough for flight testing. This was a pivotal moment, the point at which the Sabre's destiny would be decided. Would it live up to its promise in the sky? But fate had other plans. During the initial ground runs at Farnborough, a fire broke out in the engine's rotor compartment. This setback was a severe blow, not just to the development of the engine, but also to the hopes it had raised. All that power came from an Achilles heel, the sleeve valve. Forget the traditional poppet valves you see on most cars and planes, where a disc pops up and down. Napier used a cylindrical sleeve that rotated and reciprocated within the cylinder block, opening and closing the intake and exhaust ports. In theory, sleeve valves are fantastic. They allow for smoother airflow, better cooling, and a cleaner burn. In practice, under the relentless demands of a 2,000 plus horsepower wartime engine, they were brutal. The sleeve had to maintain clearances measured in the 10,000ths of an inch, finer than a human hair to avoid seizing. Lubrication was critical. If the oil broke down, the sleeve welded itself to the cylinder wall, resulting in immediate, catastrophic engine failure. It was, in engineering terms, the equivalent of walking a tightrope made out of spun glass. Mechanics often referred to the Sabre as a collection of 24 temperamental steam engines. The production crucible and the politics of power. The complexity of the Sabre meant that transitioning from the prototype shop to mass production was a nightmare. While Rolls-Royce had the infrastructure and experience to churn out Merlins by the thousands, Napier, on the other hand, struggled desperately to meet the impossible wartime tolerances required for the sleeve valves. They simply weren't set up for this precision on a massive scale. This is where the politics got fierce. The Ministry of Aircraft Production, known as MAP, was extremely nervous. They had two competing companies with high-power engines, the Rolls-Royce Merlin and later Griffin, a more conventional V12, and the unruly Sabre. The ministry desperately wanted to standardize production. Enter Sir Sidney Cam, the Hawker designer behind the Typhoon. Cam was the Sabre's political patron. He had designed the Typhoon specifically around the Sabre's compact shape and immense power. He knew that shifting to the heavier, wider Rolls-Royce engines would require a radical and time-consuming redesign. Cam fought every political directive, famously arguing that the Sabre was the only engine that could fulfill the Typhoon's low-level and high-speed role. The map's anxiety was tangible. If Napier failed to fix the reliability issues, Britain risked losing its primary short-range, high-performance fighter. Taming the Beast and the Typhoon, the tide began to turn around in 1943, thanks largely to Napier's chief engineer, Dick White, who worked tirelessly with factory teams. They didn't just redesign parts. They redefined the process. Better metallurgy, improved surface treatments, and incredibly rigorous run-in procedures for every single engine finally brought the Beast to heel. The later versions, like the Sabre B and the eventual 2,400 horsepower Sabre 5, used in the Tempest, were reliable war winners. With the reliability finally solved, the power of the Sabre transformed the war effort. The Typhoon earned the nickname Tiffy and was deployed as a devastating low-level fighter bomber. Think about the low altitude requirement. The massive power allowed the Typhoon to maintain superior speed near the ground, which was crucial for surviving heavy German flak. More importantly, when attacking targets like German convoys or tanks, the pilot needed phenomenal acceleration to pull out of a dive at the last second. The Sabre delivered that torque instantly. It was the definitive Allied anti-armor weapon during the crucial D-Day and Normandy campaign, smashing German logistics. The Sabre went from being a headache to a hero, proving that Napier's risky, brilliant design was ultimately worth the cost. It showcased a peak of piston engine technology right before the jet age took over. The Napier Sabre, a complex, volatile, and necessary power source that won a huge political and technical battle. What do you think about the trade-off between power and reliability? Was Cam right to stick with the Sabre? Drop your thoughts in the comments below. Don't forget to hit the like button, subscribe to the channel and hit the notification bell. Thanks for watching, and I will catch you next time.